Okay, before we go over the example, let's remind ourselves what a function is. A function is a correspondence between a first set, called the domain, which are the set of inputs, and a second set called the range, the set of outputs, such that each member of the domain corresponds to exactly one member in the range. I like to visualize sets using what's called an arrow diagram. So you can imagine having some kind of arrow, some domain. So we'll call this the domain here. And for instance, this might be, say, the values 1, 2, and 3. And then over here to the side, we might have another set here of the values, say this 5 square root of 2 and the square root of, say, 7, or just 7. It doesn't matter what we call it, but the point is we have something like that, and that there is the range. Okay, so then we could visualize a function or a relation, because a function is a relation, and so it might look something like this, right? You might see an arrow going to 2, from 1 to 2. That indicates that an input of 1 gives us an output of square root of 2. And then 2 gives, say, maybe an input of 2 gives us, say, an output of 7. And possibly 3, an input of 3 gives us an output of 5. And that there would yield a function. Okay, in other words, every member of the domain corresponds to exactly one member of the range. Let me go ahead and copy this picture here and just tweak it just a tad. Give you another example. Okay, let me get rid of, say, this here. Maybe it's possible that we didn't have, say, 5 there, and it looked like maybe something more like this, where an input of 1 gave us the square root of 2. 2, say, also went to the square root of 2. And 3 went to an output of 7. That there still will be a function. Okay? Because every member in the domain corresponds to exactly one member in the range. Let's see where that is violated. So let me duplicate this picture here. And what if we had something that did something like this, where 1 went to square root 2, 2 went to the square root 2, but 3 went to the 7, but then also 2 went, say, to 7 as well. Let me draw that better there. So 2 also, say, went to 7. So in this case, this violates the definition of a function because each member of the domain does not correspond to exactly one member of the range. For example, here, 2 goes to both the square root of 2 and 7. So this is not a function. Okay, so that is how I think of intuitively. Just to note, usually this next example doesn't really involve numbers, but domain and range usually are subsets of the real number, the set of real numbers. And so, but this next example is a good illustration of relations that are possibly not functions, or at least maybe one or two. So here in this example, we're asked to determine whether each of the following relations is a function. So here under the column domain, we describes the domain or the set of values, right? In this case, our first row, we have years in which a presidential election occurs. So these are years. The next row is all states in the United States. The third row, the set of all U.S. senators. So that's the domain. And somehow there's a mapping from the domain to the range. So let's just focus on the first row here, where the correspondence is the person elected. and then the range is a set of presidents. And so in this case, how would the correspondence look like? Well, for instance, our last election was in 2020, and Joe Biden was elected. And so the correspondent is for the year 2020, that gets mapped to the output of Joe Biden. Likewise, in 2016, the year 2016 would get mapped to Donald Trump. And so that's how the mapping worked. Another example, in 2008, President Barack Obama was elected. So this particular correspondence appears to be a function. All right, what about the next one? The domain is all states in the United States. The range is a set of U.S. senators. And so the correspondence is a senator from that state. Okay, so for instance, let's use our home state of California here. Well, California has this, currently has an elected senator named Alex Padilla. And we also have another senator who was appointed because of a recent death of one of our senators, not too recent ago, maybe a year or so ago. And that's LaFonza Butler. And so California would get mapped to Alex Padilla and LaFonza Butler. Likewise, Arizona, if you took, say, Arizona, I can't spell today. Arizona would get mapped to Kristen Sinema, and also mapped to Mark Kelly. And of course, that's how the mappings would work. And of course, we have other states, and they would get mapped to their senators. Each state has 2 senators, and therefore you could see this violates the definition of a function. Every member in the domain does not correspond to exactly one member in the range, and therefore this is not a function. All right, let's look at the domain for the third row here, which is the set of all U.S. senators. And the range is all states in the United States. The correspondence this time is the state a senator represents. So for instance, if we take our example of California here, Alex Padilla would get mapped or associated to California. Likewise, LaFonza Butler would get mapped to California. And you would get this type of correspondence. Likewise, if we use the other example, right, Kristen Sinema and Mark Kelly, in fact, maybe I shouldn't draw this like this here. Probably just draw 2 arrows going that way. Would get mapped to Arizona. Okay, so Kristen Sinema and Mark Kelly both go to Arizona. And that's okay because each member in the domain corresponds to exactly one member in the range. In other words, you don't see, say, Mark Kelly getting associated with Arizona and also with California. That wouldn't be allowed, right? And so in that case, this is a function.